So here we go. Got some fractions here. I like x first. Doesn't necessarily have to be, but that's just how I like it. And let's simplify this. Positive 2/3. And then, of course, I'm just going to kick the minus out front. Leave it. Quick question. What form is this in?
Sloping to 4.
Yeah. So, of course, it makes a diagonal line. For fun, is it a function?
Yes.
Yes. If I put one number in, you get how many answers out?
1.
1. Just for fun. Can't help myself. Can't help myself. All right. Let's solve this one for y. I'm going to add 2x. And, of course, we're going to divide off 3. 6/3. That comes out nice, I suppose. At least we got that. Now, to solve for y, we do have one more step here, and I know you know it. What's going to get rid of the squaring? Square root. We know. And critical detail, important detail, what do I need? Plus or minus. Now, I know it doesn't ask you here. It just wants you to solve these for y, which clearly we've done. But we should know. Would that represent a function?
No.
No. So one thing you're going to see when we have to actually in our calculators put one of these in and graph them, when you have this plus or minus, you have to put it in 2 different lines in your y equals menu. You got to do the positive and then the negative to make the overall graph. So we are going to practice graphing that today. All right, let's solve for y. This is kind of an interesting one. So I've got my x squared plus 2, my 4xy. All right, how are you going to get rid of the 4x? Divide it off. You got it. Everything by a 4x. Okay. Now, we're in trig. We should reduce. We can simplify this. X squared over x, you have more in the top. You're going to end up with just a single x up top. 2/4. I'm at least going to make that a half. Got it. So we could type that in our y equals and generate the graph, of course. Quick question, do you think that one's a function? If you're not sure, because I see this, I say, I see all the facial expressions. If you're not sure, ask yourself this question. If you pick a number to plug in there for x, I don't know, 5, how many answers will you get out? Will you get more than one answer out if I put 5 in for x? I'll get some sick fraction. I mean, it'll be ugly, obviously. If I put a 5 in there, I'm going to have a lot of gross fraction words, but I will only get one distinct answer out. This would be a function. This would be a yes, just for the record. Can't help myself. All right, just practicing, of course, solving for y, because when we graph these, you have to have them in y equals form on your graphing calculator. Now, some of this we've already talked about. I've already talked about vertical line test a little bit. You know vertical line test. There's nothing wild or crazy about that. And then we're going to do increasing, decreasing, and constant intervals today. Hopefully that sounds a little familiar to you. All right, vertical line test. Basically, of course, you have the graph. You draw a vertical line. It should only touch the graph once to be a function. So no vertical line intersects the graph at more than 1 point. If it hits the graph more than once, it is a big fat no. So this isn't on your notes. This is just for fun, some pictures here. Humor me. Is this a function?
Yes.
Yes. Function? Yes. No, it would hit twice.
No.
Nope, hit twice. Yes. Okay. That's as wild as the vertical line test gets. That's why I love it. Now, increasing, decreasing, constant. Also easy, but there's, of course, some nitpicky details to it. 1, we always look at the graphs left to right. Same order you read it. I don't know why you would look at it any other way. These have to be in interval notation. So this is all the parentheses brackets. It has to be interval style, not inequality style. And you are looking at x. And of course, increasing, we look for where the graph goes up, where it's rising, okay? Decreasing, still intervals, x. But of course, decreasing, the graph's going to be falling. And of course, you could have a constant, a flat line, straight, horizontal part. Now, you don't have to have all three of those for every graph either. You might just have increasing. You might have increase, decrease. It just depends on the graph. So don't think you need all three of these every single time. All right, so you can see we're going to kind of practice a little bit of everything today, and just to kind of make it go quicker, that's why I have some of the pictures on your notes for you, so you don't have to start redrawing them. So let's practice, we've done it, domain and range. Okay, domain, of course, x, left to right. So looking at my x-axis, we start here at 1, and we go all the way to infinity. Now, just because I have to use the intervals for increasing, decreasing, constant, I'm going to practice and do the intervals now, too. Again, I don't care if you want to write that, of course. You want to do your, x's. You're welcome to do inequalities on the homework and stuff. I don't care. But just, I know I have to do some intervals later on, so I'm just going to kind of warm it up right now. Okay, range. Y. Up and down. So I'm looking at the lowest, 0 to the highest. So I'm going to say 0 to infinity. Of course, if you wanted inequality, y is greater than or equal to 0. And you can do it either way. It doesn't matter to me on the homework. Just practicing. All right, our very lovely parabola. Well, I can get you the domain on a parabola without even the picture. I can square any number, positive, negative, fraction, decimal. I can square anything and I'll get an answer. Plus, your parabola is going to go all the way to the left, all the way to the right off the screen. So we could say all real numbers. Just because I'm on this interval notation kick, I'm going to say negative infinity to infinity. You're welcome to just say all real numbers. I don't care. Okay, range. Lowest to highest. Lowest right here at 1. Our highest is going to be up to infinity. And just like that, the first page is done. Any questions on those domains and ranges? Okay, flip it. We have one more. Absolute value. We know it makes a V. That's nothing exciting. Of course, thinking about my domain, left to right, all the way left, all the way right. We can put any number we want in here for x. So all real numbers. Can't write and talk here. D, I'm trying to write. You can use your negative infinity to infinity. I don't care, remember. Okay, range. Lowest to highest. You tell me what's the lowest on your range. You're starting at what? 0. And it would end at infinity. Got it. So just a little domain and range practice off the graphs. We've done that. This is nothing wild or crazy, my friends. Any questions I can answer on those? All right, let's carry on then. Use the vertical line test to determine if it's a function. Now, you can use your graphing calculator to generate the graph for this if you want. I don't care. But we should be able to do it in our heads. X squared, what sort of shape is it going to be? Parabola. So this is our parent function, parabola. So I know 0 squared is 0. I know 1 squared is 1. I know 2 squared is 4. Let me get some numbers on the left here. We need the left side of it. I know negative 1 squared is 1. And I know negative 2 squared is 4. Lovely parabola. And again, even if I ask you to make the graph, don't think you have to do it by hand. You could still do this on your calculator and get some points off the T-chart. I don't care. All right, let's answer the real question though. What is it a function?
Yes.
Yes, passes the vertical line test. Got it. Too easy. Okay, I see some of us using our calculators for this guy here. So let's take a look at this. My marker there, that would have been bad. Move this thing. That's what I want to do. Okay. All right, so let's solve for y. I'm going to subtract x over. I'm going to switch the signs because I like y to be positive. Probably some of you without even the graph can get a hint of if this is going to be a function or not. because we have to throw a plus or a minus on. So right now, is it going to be a function? I can tell you it's a big fat no because of the plus minus, okay? But this is really more of a calculator practice situation to get the graph on here, okay? So you don't have to graph it by hand. We can still use our calculators. So let me pull it up here. When you type it in your y equals, you're going to have two equations in here. You're going to have just the positive one. I'm not putting a positive symbol. I'm just typing in the square root of x minus 1. Maybe. And then you have to put in the second line. You have to throw the negative in front of it. And now type in your square root x minus 1. And I'm going to hit graph. And we can clearly see that would not pass the vertical line test, okay? Now, I'm just going to get a couple points off the T-chart so I can kind of plot it and make it look good. So let's pull up the table. Let's see. So I'm going to plot 1, 0. I'm going to do 2, 1. I'm going to do 2, negative 1. So 1, 0, 1, 0, 2, 1, 2, negative 1. Good enough. And we knew from the get-go with the plus minus we wouldn't be a function, okay? Any questions on that guy? All right, next graph to do. Let's solve for y, of course. I'm going to add 1. Kind of like the warm-up problem. This is going to get a little fractioning on us. We're going to divide by 2x. Now, you could just type in the left side right now as it appears and go for it. Personally, I like to, well, I hate typing on the calculators. You know, I'm going to reduce this just so it's a little less typing for me. X squared over x would just be a single x on top. Now, we are going to look at the graph, but we should be able to know right now, is this going to be a function? If you put a number in for x, will you get one answer out?
Yes.
Yeah, it'll be gross fraction, but yeah, sure will. So this is really more of a calculator graphing deal. Let's punch this guy in. Y equals, let me clear all this stuff out. Okay, so I don't know if you know this or not. This one's not bad to type in. Of course, a lot of times your fraction bar, you can use division. So I like to pull up the horizontal fraction bar so I don't have to worry about like use of parentheses or anything. If you hit alpha y equals, you can pull up a horizontal fraction bar so it looks exactly what's written on your paper. Not that using the division slash is wrong, but if you had crazier functions with more expressions in there, it might be some order of operation problems. 1 over 2x, got it. Let's hit a graph on that. Well, like last hour, a kid said it looks like 2 hockey sticks. Kind of see that, I suppose. Okay, question is, we know it passes the vertical line test. It will only hit once. If you draw it here, it will only hit on that part once, this side once, etc. Now this one's kind of a pain to draw. Let's get a couple points off the T-chart. Oh, let's see. I'm going to do -1, -1. Let's see, 5/4 is 1 1/4. I'm going to estimate it. So -1. There was 1 1 on it. What else was on here? Let's do 2 1 1/4. And then I'm going to do -2 -1 1/4. And again, you know my artistic skills. I'm not looking for perfection. I'm just going to kind of draw that. I'm going to try to draw it best I can. Got it. Hopefully your artistic skills are better than mine. All right, last thing we have today, increasing, decreasing, constant. Now remember, you do not have to have all 3 for every single graph. We're going to follow the graph from left to right. We're going to determine if it's rising or falling or staying the same. Open intervals, so no brackets, and I'll talk about why in a second. But open intervals, interval notation for the x coordinates. All right, let's follow the graph left to right. So if I start here, following the graph, it's clearly falling. So we just have a decrease interval. We start at 0, and it goes all the way to infinity. So there's no increase, no constant. You can leave them blank, you want to cross them off, whatever you want to do. Remember, not every graph has to have all three. All right, next up. It's nice when the pictures are already there. Same thing, follow left to right. I'm going to start down here at the left. Ooh, okay, right. So now we're rising. So that's my increasing interval. Again, start at x. We're really at negative infinity to 0. Start with that one. I'm going to keep on following. Notice I switched colors because, ooh, yeah, now it's falling. So decreasing. We left off at 0. Now I need the x coordinate of this point, 2. Make sure you use x, not y. That's an easy thing to just accidentally use the y instead of the x. All right, carry on. It is now, as I follow it left to right, rising. So we have another increasing from 2 to infinity. Need a longer blank here. No constant. Now, this is why it says open intervals, because like 2 is in 0. 2 is in multiple intervals. That's where it's rotating from increase to decrease. So that's why they're using open intervals versus the brackets and the closed ones, because it ends up being sometimes in more than one. All right, this is a good one. Hannah.
Can we use inequalities for this as too? Like for the first one, can I do like x is greater than or equal to 0?
Remember, for these, it has to be interval notation.
Okay.
Has to be, yep. Okay, absolute value, I know you know, it's in your math menu under num, but just if you ever need to find it, here it is. Now, this one has, of course, all 3. Follow left to right. Clearly we're rising, that's my increase interval. So again, x, negative infinity. And of course, I'm like, okay, what's the x coordinate of this point? Negative 4. Now you have your flat line. So there's my constant interval. And we left off at negative 4. X coordinate, negative 1. Got it. And then I carry on. We're decreasing from negative 1 off to infinity. Got it. Any questions on that? Now, the only reason I'm making you do this last one, so I can mostly complain about Texas Instruments. All right, let's use your calculator. You don't have to draw it by hand, people. X. Clear this off. What is it to be minus x? So, I mean, looks pretty, basic, right? Nothing crazy. Here's my question to you. Is 3, 0 a point on the graph? Look at the picture. It looks like a no, right? Looks like a no. When I look in the table, is 3, 0 a point on the graph? Hate you, Texas Instruments. Okay, so this is my whole spiel on this one. Is you can't always trust the actual picture or the graph on your calculator. I think it's because of it's so pixelated, it's technology. I don't always trust the picture that they give me. That should be connected. When you draw it, it's really 3, 0. It hits there. If you look at some other points, too many windows open. If you look at some other points, what else do we have? We've got 2, 2. I've got 0, 0. Let's put those on. 2, 2, 0, 0. So it does connect. That's the only reason I made you draw this one, is so I could complain about Texas Instruments. All right, follow the graph, left to right. Let's do it. So clear out here at the left. Increasing, rising, 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 rising. Bam, here's where we switch. So we're from negative infinity. And x coordinate of this point, x is, and then of course we start to fall as we continue, and our interval on that, x is 2 to 3. No constant. Got it. So just be conscientious of your calculator. I always usually try to check the table if I'm questioning the picture. Man, Texas Instruments, get it together.